So hello everyone, today we will start learning this mass, weight and density. So first of all, mass. Mass is a measure of quantity of matter of an object at rest or relative to the observer. Mass is scalar quantity, so it doesn't have this type of direction. The SI unit for mass is kilogram, so it would be better if we converted it from any type of this unit to kilogram to make sure that it's in SI unit. So that's why mass is property of an object that resists change in motion. If the higher or the greater the mass of an object, this would get more difficult to speed it up, slow it down, or change its direction. So for example, if two cars collide, the one with a higher mass would not get that damage or wouldn't change its direction compared to the one with smaller mass. A mass may sometimes be given in grams, so we can convert it to kilogram. If 1000 grams equals to 1 kilogram, that's why 1 gram equals to 0.001 kilogram. So example, an object is 2.7 kilograms. State the number of grams in 2.7 kilograms. That means convert 2.7 kilograms to grams. So to do so, we will multiply it by 1000, and this would be 2700. As you can see here. Weight. So weight is also similar to mass, but weight is gravitational force on an object with mass. So that's why weight is force, and consequently it is a vector quantity. The SI unit for force is Newton, and weight is also called effect of gravitational field on mass. So we can also call it or define it force acting on an object due to gravitational attraction. Planets have stronger gravitational fields, so that's why the object can have higher weight on Jupiter compared to on Earth. Because of weight, the satellites also will keep moving around Earth, and objects fall into the ground, and all objects stay firmly on the ground. Weight of a body equals to mass times gravitational acceleration. On Earth, it's approximately 9.81. Sometimes it's used 9.8 or 10 Newton over kilogram in this context. Or we can use meter over second square if it's referred to as acceleration. You can rearrange this equation to use with your fingers, as we did in our previous videos, or you can just use this formula. The gravitational field strength. And gravitational field strength is also defined as the force per unit of on an object in gravitational field. So on Earth, as I mentioned before, it's 9.81 or 9.8 or 10 when estimated. So in this context, if it's referred to free fall or acceleration due to gravity, it's meter over second square, but in our context, it's a Newton over kilogram. So as you can see here, planets have different gravitational field strengths. Sun has the highest one among Jupiter, Saturn, Uranus, Earth, Mars, and Moon. Mass and weight versus weight. So, for example, a man has 70 kilogram mass. On Earth, he has got 687 newtons weight, but if he goes to the Moon, he has only 114 newtons weight. So as you can see, difference is really big, and this is due to this difference in gravitational field strength. On the Moon, your mass will stay same, but your weight will be much lower. So using a balance, I think all of you know how to use balance, and the weight of two objects can be compared using this balance, or you can use this formula because the G is always the same, nearly always the same on Earth. Balance can be used to compare to different weights. So as you can see, there are different types of balances used by people. So now density. So density is defined as the mass per unit volume of material. So objects made from low density materials typically have a low mass, but it doesn't mean that it's always. Similarly, the objects that from high density has a higher mass if their volumes are same. For example, a bag full of feathers is lighter compared to a bag full of this metal. So density is used can be calculated by this formula: it's mass over volume. And its unit would be kilogram over meter cube. Gases are less dense than solids because their molecules are spread out. So as you can see here, if something is more dense, its molecules would be much closer to each other, and if they are not and they are spread out, it would be less dense. So for this reason, gases are less dense than solids. So this equation can be rearranged to use your fingers, or you can just use this formula itself. So the units of density depend on mass and volume. For example, if you have kilogram and meters cube, you would use kilogram over meter cube. So there is table of some more commonly used materials table on kilogram over meter cube. All of them are estimated. So for example, air has 1.3, whereas water has 1000, and lead has 11,300. So sometimes you are not you don't have volume of an object. You can directly sometimes it's not possible to directly calculate its volume, but for some shapes there are formulas which you can use to calculate volumes. For example, cube has got easiest formula, I think. It's dimension cube, and the sphere has 4/3 p r cube, and cylinder has p r square times L. These volumes of common 3D shapes. If you want these volumes of other shapes, you can search it or Google it, and you can easily find it. A paving slab has a mass of 73 kilograms and dimensions of this 0.04 meters, 0.5 meters, and 0.85 meters. Calculate its density in kilogram over meter cube. So first of all, we need to calculate its this volume. So for this, we can multiply all the sides. 0.4 times 0.5 times 0.85. This is 0.017. Now kilogram 73 over 0.017. So as you can see here, it's approximately 4,300 kilogram over meter square. So goodbye. Follow for more videos that helps you to get higher grades and higher levels.